Hello, Chicago. I am Chris Burns. I am a senior AI/ML solutions architect at Amazon Web Services. That sounds like a mouthful, but it really isn't. Essentially, I help our customers and our partners build AI solutions on AWS. It might be easier for me to just introduce myself with what I do rather than what my title is. So I'm thrilled to be here today. Thrilled to spend some time with you, share some time with you, some stories. Before I get started, there's a couple of things I wanted to share. One, days like this reinforce my decision to have a hairstyle such as I do. And another piece of information is June 2018 marks 25 years for me, 25 years of experience in either application development or mechanical engineering. That's going to become relevant in just a couple of moments. And the final piece I wanted to share with you is I suffer from a variation of something called chronological snobbery. Has anybody ever heard of that phrase, chronological snobbery? In his autobiography, C.S. Lewis used it to define the argument that past generations' art and science and thinking and technology and general intelligence was less than that of the current generations because of technological advancements. Went from bad to worse there. So I suffer from a variation of that because I don't believe past generations were any less intelligent than we are today, by no means. I do wholeheartedly believe that our generation it has dealt with a pace of change that no other generation before us has had to deal with. And today I'm going to talk about technological convergence. I'm going to do it in 4 parts. I'm going to talk about what it is. We're going to try to define it, put a couple of labels on it. Then we're going to make some observations about it in part 2 about how can technologists and architects and developers, how can we deal with that? The third part of it, I'm going to talk about user interfaces. And when I say user interface, I mean how do we as humans interact with technologies? How do our technologies interact with technologies? And some key notes around that. And then finally, I'm going to give you a couple tips about how we as humans can best adapt to this pace of change. So back to part 1 now. What is technological convergence defined? It's, as you might expect, it is defined by one or more technologies coming together to create something new, a new technology. It goes by several different names. I've used this phrase recombinant technologies before. Recombinant technology is a technology that inherently changes anything it touches. Am I switching to this? Just the hand mic now? Okay. So, can everybody hear me okay? Could you hear me for the first couple minutes? Okay. So, recombinant technologies. Now, today's not about AI and ML specifically, but it seems like everything these days are about AI and ML, which is good for me, actually. But so AI and ML is recombinant technology. It changes whatever it touches. Jeff Bezos, if you've ever heard of Mr. Bezos, he defines AI and ML as a horizontal enabling layer that cuts across all industries, all verticals, and changes whatever it touches. So, I'm not using slides today, if you've noticed that. So I put the burden on myself as a speaker to paint a vivid picture for you. So I'll try to do a good job at that. And then finally, a little bit of bad news. There's been some great talks this morning. I'm a little mindful that I'm following up some pretty great conversations, and I'm not going to be able to get into speculative nature and theory and some of these really cool topics today. I'm going to keep it leveled in the here and now. And I do not have slides, but there will be some people walking around passing these out. I got about 50 or 60 of these. So better than slides, I have a little trinket. So if you don't get one, don't worry about it. It'll make sense at the end of the presentation what they are. So now back to technological convergence. We've defined it. We've given it a couple more names, recombinant technologies. So a couple of examples that I'll give is IT. The phrase IT. If there's any phrase that's changed its definition more than IT, I don't know what it is. And if you think about IT today, it was very easy to define 10 or 15 years ago, but today let's take computer-aided manufacturing, for instance. If we define IT as the point by which information becomes digital and then has to be managed as an IT asset, then what about computer-aided manufacturing? So these mechanisms
are using computer vision. They're using natural language processing, sensor fusion. So the lines get blurred between what is IT and what's traditional manufacturing very easily. That's a great example of digital convergence. Another example is the smartphone. I know it's a tired example, but I'll just touch on it for a minute. Our phones today, I can, of course, make a phone call from them, which is good, but I can also text, I can also email, I can also browse. In some ways, it's supplanted the responsibilities of the PC. Now, the newest of the new smartphones, they also have sensors like accelerometers, gyroscopes, proximity sensors. They have compasses. If you're an Uber geek, you call that a magnetometer or something like that, GPSs. And what it does is it gives the developers the ability to create more immersive applications and experiences for the end users. So I want to real quick level set on AI and ML. It's in my title as an employee. I find that even though we've all heard this phrase, anybody not heard of AI/ML? Okay. What I do with my workshops is usually the first question is I pick a volunteer, I pick somebody who's not paying attention, I ask them, tell me the difference between AI and ML. Why do I always see these two together, but yet the definitions aren't quite interchangeable? So if you saw Mr. Barrett's talk earlier today, he had a nice definition of AI, and so I'm going to offer up my own definition of AI. AI is it's the capability of a machine to imitate intelligent human tasks. Now, when we talk about a machine, that could be a software-based machine, it could be a hardware-based machine, it could be a mix of the two. And when we talk about intelligent human tasks, we're talking about sight and speech, the ability to think, cognition, hear. So we have a lot of translated technologies there, text to speech, speech to text. That's what AI is. Now, ML is a codified mathematical algorithm that can read and find patterns in large data sets. It can learn from data. So to bring this home here, to give you an example, I'm going to use Alexa. Alexa is an example of AI. It's a persona. AI is almost an abstract creation rather than a concrete item. And Alexa sits atop the AWS and the Amazon natural language processing services. So I wouldn't interact with a natural language processing algorithm. That would be awkward. I interact with Alexa. So just to get back on track here, one of the another example I want to use, I'm going to pick on IoT for just a minute. And I don't mean to pick. I love IoT. I spent a lot of time in my career on IoT. But let's take what we call an IoT project. The spirit of IoT was the device-to-device communication without human intervention. So that's great, but that doesn't actually solve a business problem. In order to solve a business problem, we need a bigger solution, a grander solution. So if you want your devices to be intelligent, you're going to layer machine learning on top of it. So now, is it a machine learning project or is it an IoT project? You have to run that somewhere. You may have sensors in the field, but you're going to have infrastructure somewhere. So traditional architecture is now layered into the mix. You're going to have software. So you're going to have DevOps. So at what point is an IoT project just an IoT project? It doesn't exist, to be honest with you. This is that convergence that we're going to spend the next 11 minutes on. So AWS has positioned itself, I think, very, very well, because the other point I want to make about this IoT project or ML project is these don't exist in a vacuum. You can't jump on this new technology, this new hotness, and then put it out there on a house of cards. You have to have a fundamental infrastructure underneath that. So we go back to the very fundamentals of cloud: compute, network, storage, and then you get into the nuts and bolts that people don't like to talk about. You have logging, you have auditing, you have access and control systems. So that's really the definition of technological convergence. Hopefully I didn't butcher that too much. And I want to get on to the next topic now about what observations can we make about that for the developers, the architects, the technologists, which by the way, if you think you are not a technologist, it is 2018 and we are all technologists. So what observations can we make about that? I'm going to quickly tell a personal story. I used to be a software developer, dedicated software developer. It's all I did for hours and hours and hours a day. And I found that I wasn't content with just knowing server-side code. I had to know presentation layer code, visualizations, network code. And so I would continue to grow those skills as a software developer until eventually I realized if I wanted to expand my horizons, I had to stop focusing so much on software. And today I still write code almost every day, but I'm not a developer. I call myself a software composer. I like to use Python a lot. Python's a great example of this because I can get more done in Python without actually writing anything by just pulling from libraries that other people have created. So there's, get back on track. See, this is the point in the presentation where I'm regretting not having the slides. So a couple of tips that I wanted to give you as, for how do you deal with this convergence. And one is, they're all human skills, luckily. The one is the ability to dive deep. You have to be able to dive deep on a topic, but you have to have the restraint to not focus on a technology too much. So every time I see new technology come out, my first instinct is to just jump on it and spend as much time as I can and learn as much as I can about it. But that doesn't help me with big picture thinking, with a think big. But the ability to dive deep when I need to and only when I need to is critical. The other trait you really should have is you need to learn and be curious. Constantly learning. You can't fear a learning curve if you're in this business. Another one is invent and simplify. When you have 5 or 6 or 7 different technologies coming at you once, you have to see how they work together. You have to be able to simplify those processes. Another one is to fail fast. We've been ingrained since we were children that failure is bad. Failure is not bad. We all have heard that famous quote from Thomas Edison where he didn't fail to create the light bulb, 10,000 times. He just figured 10,000 ways to not make the light bulb. So when it comes to technology such as cloud technologies or these applications that you see today, POCs are your best friend. A proof of concept means, does this idea work? If the idea does not work, that doesn't mean you failed. That means you've said, okay, check that box. We're going to go a different route. And then finally, you have to learn to use new tools. I try to use new tools all the time. As a matter of fact, I spend an extraordinary amount of time on using new tools. I'm going to use this shirt as an example. I didn't pick out this shirt, and my wife didn't pick out this shirt. This shirt was picked out by AI, and it gives me a whole bunch of confidence that I might not have when I came out here to talk to everybody today. So, did anybody hear the song playing when I came out? I know it's a little bit of background noise. Did anybody recognize it? Hopefully one person at least recognized it. Nobody? Okay. So it's another form of convergence. It's digital convergence. It's also my favorite kind of music right now. Absolute favorite. I'm going to show my age here, but it's heavy metal remixes of 80s songs. So I don't know why I like that music so much. I've thought a lot about it, and the best conclusion I can come up with is that I grew up in the 80s, so it was very influential. Best decade of music man has ever created. And then when I got older, I got adult responsibilities and kids and taxes and work and angst. I started listening to a lot of heavy metal. I like the energy. My wife has many other names for it, but I like the energy of it. And so when you have this convergence of those two, it really creates this very interesting experience. I know it sounds a little bit silly almost, but when you sit and think about it for a minute, it's very thought-provoking. All right, so let me get back on track here. I told you about interfaces. We'll talk about interfaces. When I say interface, if you're a developer or an architect, you're probably going to immediately gravitate to a graphical user interface. That piece of software that we use. I don't want you to think of interfaces strictly as a GUI. It could be a GUI, but think of an interface as how humans interact with technology. So, give a quick example. We've all heard that our manufacturing economy, excuse me, I'm going to get a sip, is moving to a service economy. And we've also heard that our service economy is actually becoming an experiences economy. Excuse me. So what does that mean for technologists? If the product is an experience, that means we can no longer be the geeks in the back room rolling code. We have to understand every aspect of this process. These convergences, I was having a conversation just today where you might create this fantastic computer vision solution to a problem, but if you can't implement that in the physical world, it's not going to help too much. So an interface is how we interact with our technology. And a great exercise to help you think about this is take a morning, take an afternoon, take a day, and everything you do, whether you're using a pen or pressing a key on a keyboard, flipping a switch, think, how could I do this with my voice? Or better yet, how can I do it with just my presence? When I want to have a conversation with somebody, I don't walk up to them and bop them, hey, I don't push a button. my presence initiates that conversation. So think about that. And then I'm going to get to the final point of today here. And the final point is, what can we do as humans? I'll stay on topic with the day to help us with convergence. And did these get passed out? Did anybody get any of these? Okay, so they're out there. Good. So this is a story I tell every workshop I give, every talk I give, regardless of the size. So I do apologize if you didn't get one. They have no monetary value. I told you this is 25 years for me. I spent 7 years as a mechanical engineer building and installing and programming industrial robots in the 90s. It was great at first, but then hindsight's 2020, of course. What I didn't know then that I know now is that we just didn't have the technology to do what I thought was possible. So I read an article about 2-3 years ago about 3D printing, and the author said that 3D printing was going to create manufacturing processes never before possible. And I took offense to that. I was very defensive. I said, what's this guy talking about? I considered myself knowledgeable about manufacturing processes. So immediately I had to investigate. I went out, I bought a printer, did some research on what he meant by that, and I found this model. Now this doesn't serve any function other than to prove a point. You wouldn't see this anywhere in manufacturing. It's just some satellite gears inside a ring. So I printed it, I took it up, and I studied it for a couple minutes, and it was really, all joking aside, it was a very profound moment for me because I realized, not that the blogger was right, but something that I was wrong about. I had lived for 20 years thinking that I understood something was a ground truth to me, that I understood manufacturing processes, that they progressed only linearly, there's no such thing as overnight change, and I was wrong. This little 3D printer did something that I could not do today if you dropped me into the most state-of-the-art manufacturing facility. This little ring of gears was printed all at once. I popped it off the bed and it just started moving. The gears aren't going to fall out. I can't do that. Nobody can do this with traditional manufacturing. You'd have to break this ring, assemble it, put it back together. So the bigger picture here, what I realized, and I guess this is a critical thinking exercise, is that something that I thought was a ground truth was really a bias. And this woke me up to this bias that I was carrying. And I see that pattern again. I see that pattern again today with AI and ML tools and solutions. So AWS, we know that the pace of innovation is ridiculous, and we recognize that, and we kind of put our money where our mouth is. In 2017, we released 1,430 new features and services. In 2016, it was 1,017. The year before that, it was 722. The pace of change is staggering. And what I realized with this little example is that we now have tools as technologists, as developers, as journalists, as writers. Anybody can use these tools based on AI and ML to create processes that have never before been possible. And so that's my challenge whenever I give this a talk similar to this. My challenge to you is use these tools, understand what these tools are, and go out there and create wonderful, wonderful things that have never before been possible. So that's about it for me. That's my time. I want to thank you very much for interrupting your lunch and listening to me talk. And if you have any questions, feel free. I'll be around afterwards. Thank you.